here and we're going to do this. Thanks everybody for coming. This is going to be a slightly technical, not too technical, introduction to something we've been working on for about 3 years. I'll give you a real quick background about Andromeda, where we came from, sort of the story, bears and bulls, Terra crashes, and everything mixed in. We got our first grant from the Terra community back in 2021. That was a $115,000 grant in Luna. When it was $5, we rode that all the way up to about $100. So it was a small grant turned into a pretty large grant. Went through our pre-seed round and raised quite a bit of cash, and then held that in UST, and well, we know how that worked out. So blockchain giveth, blockchain taketh away. Let's see. So the idea here is really, it started with sort of my background. So I started in computer science back in 1992, 1993. I'm 42 years old, so if you do the math, carry the one. I started programming when I was 10 years old. And at that time, I got into Linux and the open source movement. I got into sort of the free culture around sharing software and building really innovative solutions. And so as we got into this sort of blockchain era, we started seeing smart contracts with Ethereum 10 years ago. Ethereum proved the need for these smart contracts. And if you look at these blockchains, they're really just state machines with an abstracted hardware layer. And if you look at the speed at which these chains operate, and you compare that to a computer of yesteryear, you're looking at computers in the late 1960s or early 1970s, best case. And so if you look at the way that these patterns that evolve with computing, is once you start to stabilize the previous generation, you need sort of abstraction, and there's a pattern you can follow. So with that, we decided to start with the very first on-chain operating system. And that sounds like a buzzword, I realize, but we're going to get into the technicals about this, and I can justify every word I say and every promise I make. So here's the key topics we'll be getting into. So core systems, let's see here. So
I can also step in here a little bit. So, hi guys, thanks for being here. We'll go into more technical rundowns of these processes as we go through a little bit more, and I'll have a little bit more to say. But in general, when we talk about kind of the core systems, we're going to be talking about, this is primarily developed at the smart contract level, and we're not looking at the lower chain level. The architecture for that is kind of supplemented with some additional parts that we have in some of our messaging protocols and other things as well. We'll be looking at some of the implementations as they work, but the core system is designed to be deployed on multiple chains, not a single chain. We're very chain agnostic, focused very specifically on just facilitating development for anyone that's sitting in the Cosmos space. Our logic library is essentially a open collective, as we can see, a community contributable open source library of kind of smart contract systems. We'll talk more about what those are that makes an enhancement for that. But essentially creating a community contributable logic library that everyone can use.
Which is something that was seen in something like Debian with Debian Package Manager, if you're familiar with that, where you can just kind of apt-get install applications. They come off the shelf, they're sort of pre-audited in this case, and vetted by the community. So AMP is a really big component of this, and that stands for, it's a cool name besides AMP, but it's Andromeda Messaging Protocol. Sometimes the acronyms work in your favor. And what AMP does is, AMP is the way that all of the different objects and all the different systems and subsystems communicate. And that's the common thread behind that. AMP runs on top of IBC, so any chain that's connected with IBC, we can run these AMP packets across. And that has things, that has all the information about the user, maybe a position on the file system. I'll get to these in a minute. And this is all run through the kernel. So we have the base piece here is you've got a kernel, which is a set of smart contracts that kind of create a user space for anybody to operate inside of. That enforces usernames instead of just keys. Instead of just running around with naked keys, you get key rotation for free out of this. You get the file system, which we'll get into I think in just a second. And when I say file system, I'm using words that we can kind of point to and recognize. If you want to get into the specifics about, it's not a file system because there's an inode and a sector on a hard drive, we can get into that, but we're trying to use common vernacular that everybody understands.
We'll also go over the tool suite. I'll spend a little bit more time there introducing you guys to the tool set that we have now and kind of what the implementations are for that, what to expect as we move forward as well. We'll talk a little bit about release plans. We're a little shy on putting dates on things, but we have some opportunities to kind of give you an idea of where we actually stand right now and what we're anticipating to come after that. And then we'll also go into talking about where you can get involved in the contributions to what we're trying to build. So we'll start out with kind of core systems here. We did kind of a brief explanation, but we'll maybe dive in a little bit more because I think we need to talk a little bit about the subsystems and the design patterns that we've kind of addressed with that a little bit more. And they let you speak about that for a sec here, Cody.
About design patterns?
Yeah.
So, yeah, history repeats itself. So if you go back into the 1970s and start looking at how the different mainframes and Unix systems and variants were created, really we're doing all that all over again. Instead of calling it Internet Protocol, we're calling it IBC in this case. And there's like you can start building an OSI model, which is what we use in the Web 2.0 world and prior. Operating systems have there are a lot of great things we can pull from there. So modularity. When I say modularity, I mean at the smart contract layer, not what Celestia and all these guys are using as modularity. So really, just taking a lot of these patterns and saying, how can we adapt these things to a different substrate in blockchain?
And so we've got a couple of references. I'm not going to dive into them, but kind of looking at the comparisons of the traditional OS versus that build out, and kind of where we map our architecture in the larger scale of these implementations.
Yeah. This is a really important slide. I need everybody to memorize every piece of this.
Yeah.
I'm kidding. This is all on-chain stuff. So all the pink pieces are the places where aOS and our system kind of plug in. And these are the validators. This is kind of this same stack condensed into like one chain, so we would have multiple chains where this stack is installed. And like Leif said, these are all smart contracts, so this doesn't require a chain upgrade by any means. All you have to have is CosmWasm enabled, and then some level of IBC 7.2, I think, is what we require. But after that, we can install this across potentially 60, 70, 100, 200 chains in the Cosmos, and we're pretty agnostic.
And we're not going into the details today, but the white paper has that. It's available. We'll get you links at the end of this as well.
60 pages of great reading.
Yeah, so if you really want to get on the technical dive and see what the breakouts on those builds are and kind of the patterning that we're using, as well as information that we're not able to get to because there's no way we have enough time slotted today for all the things we really have to address, I'm going to be encouraging you to go there, and those references are listed there. Logic library. Essentially, let's get started out with what it contains, and I may let you break out.
Yeah, so in 2017, I was one of the creators of the ERC 721 standard, so all those monkey pictures you can blame me on, all those floor prices we were all counting on, I have something to do with that. When we created NFTs, there were a lot of things that I advocated for, and one of them was like not calling them NFTs. It tells you what it isn't. It's a non-fungible, yeah, okay, I know what it isn't now, but what is it? Well, really, it's a digital object, right? So if you're into programming, you can say it's an object, it's unique, and we just appended the Andromeda piece to the beginning of it. So these ADOs, you can think of them as sort of like files, maybe, right? And now, I don't want to get into the hard drive and sector talk about what a file is, but think of them in an operating system as a unit. It's the smallest unit of measure. And so these ADOs can be stitched together. In Linux and Unix, you have this philosophy of when you create a command line tool, you do one thing, you do it really well. Right? You don't want to create these large applications on the command line, you stitch them together. So you have things like grep and cat and ls and find, there's all these different commands, and that's essentially how we architected these ADOs.
There's a degree of inheritance that's applied there at the kind of the base ADO level, providing that every ADO has a lot of interoperability options, permissioning and other structures that are kind of dynamically inherited, which is kind of an extension of what we would just traditionally think as a smart contract. But they're designed to be able to work together. And we've been trying to showcase how that works as far as general interactions. So your foundational bases at a CW20 or a 721, and what would some particular uses be? So we've been trying to outline and highlight these particular, kind of examplings which we are coming through and I'll discuss a little bit more later. But this is more of kind of a sampling with the idea that these are things that we're anticipating for the community to be able to build, add to the ADO selections that are available, and not be something that we specifically are doing. We've created kind of base submission standards that they're very easy to implement, but they meet to that inheritance option and how to get them compliant with the message protocol systems and stuff that we'll talk about here as well. But that library being dynamically expandable, something that the community can contribute to as individuals or groups or just general organizations. We've created both this system and all of our support tooling to be allowed to just dynamically populate. There are approval and verification processes, important to note. It's not just anything, but that's just because we have a responsibility of stewardship to that. I won't go too deep in apps. It'll make a little more sense in context, but essentially we've created extending the functionality for encapsulation of these independent objects. As we were talking, we have marketplaces related to our 721s. That organizational process of putting those pieces together that are designed to operate together generally need some form of encapsulation. That can be for organizational purposes like a folder or file system, but in addition, this is also a general form of parent-child relationships, that intercommunication capacity. Part of our structures also facilitate for us to do pre-deployments. So in a more traditional smart contract implementation where you want to reference the functionality or unit on the other set, you'll need to deploy and then grab the instantiated contract address and then put that in place. And instead we've developed the system so that you can actually anticipate where you're going to be deploying using self-referencing and that child and parent communication references, so that you can do one full instantiation of all your component pieces and not have to be looking at sequential deployments. And what that is, and having to work with things with long contract addresses, and keeping that simple and more straightforward for the user and more intuitive and easier to understand.
Covered AMP for the most part, and that's just how all these different objects communicate with each other. It's a higher level of order. We're adding more sophistication and more intelligence to that. The kernel,
So we'll get a good example here in just a minute to just kind of try and explain contextualize what Cody was referring to previously. But the kernel working at that fundamental core level. As I mentioned, not every ADO, just not everything can be built. We have a verification process. And part of that is to actually have certified Andromeda packages. So there's an authentication level, and this is really important because the ADOs and the other contracts can be audited and maintained by the community, and eventually from kind of a DAO to be able to actually, stay involved in what gets approved to move forward in the official versions of things. And that's handled by AMP, so that's integrated into this processing system. The virtualized file system as well, and I'm going to let Cody go off a little bit more on it.
So this we basically ripped off the same thing we see in Unix. You have like /home/username, and then you have your different objects and different applications and different components inside there. You own them by your username. If you want to swap out your key, because you want to do proper key rotation, and you've got all these different objects, you can abstract these things out and swap them out based on a username. You can have multi-sig for your own username. You can do whatever you want downstream from there, but you sort of need a common area. VFS also allows us to have like /etc. So if you're familiar with Unix, everybody here is somewhat familiar with Unix. There's an etc folder, there's a var, there's a sys where you can go and like ask for block time or current block with a URL, a path. Instead of having to like query some random string, if you're not a Rust user, you can't get to that information, right? But if you just need to grab that information, you can just reference the file system we've created, and all those objects are there. We're just abstracting this stuff a couple layers higher, so it's easier for people to start addressing.
Yeah, and as I was referencing before, with kind of simplifying the namespace for being able to reference these objects and interaction points, that VFS becomes really valuable because now I can just refer to, say, if I have a rates unit that's going to take a small deduction off of the transactions on a sale, I can refer to it. We have substitution operators that you might be commonly familiar with, such as the tilde for home or the dot operator for current path. So currently within that structure.
So I could use proper globbing and all the
So I can use a reference that way, and I could use a /rates and refer to it that way and not have to worry about that. In addition, it also works on our IBC level, and we use the same standards that we see in HTTPS. We're using IBC, so AMP will be over IBC as our initial, but we can declare that protocol type,
XLR,
IBC,
CCTP,
the
or
chain
whatever.
source that we're looking to, and the file structure system for that. So if you're looking at your cross-chain referencing and need to have interactions on cross-chain units, that will be done there. When you need to share that with someone else, you can do that based off the path. This also operates for the facility, as Cody mentioned, for those base routes like etc and lib, and those communal kind of uses that aren't going to need to be independently managed or handled yourself.
So all of this is on chain, I should say. All of this information, all of these operators, all of this stuff happens on chain, right? We do have a CLI, which you can run on your laptop and do a lot of querying and reading off the chain. But anytime you write through this whole system, through this kernel, 20,000 lines of code that manages this environment. That's really, really important. On the AMP piece, when you're sending messages across, this is IBC://. Now we're talking about how we're going to communicate, like what vernacular. Then there's a host name, which is what chain you're talking to, right? And then a slash, and then the path to the resource. So we're using the same concepts that we've been using for 40, 50, 60 years in computing and just bringing them on top of this so that it's easier, better, faster for people to build.
And the way that we're generally handling that cross-chain communication and interoperability, and I'll give you a little diagram in a sec here, we've essentially created a series of packets and messages to encapsulate your standard execute messages and things of that nature. It gives us some different routing and processing configurations, how you want to respond to replies, how to perform for exits, but also allows us to perform batch processing, so we can have sequential deployments of multiple executions intended to run all within sequence, just dynamically by defining those in the AMP packets, essentially a vector of my deployment that I want to do in a sequential process. As kind of a general breakdown of what we were looking at there, talking about the kernel becomes that primary communication piece for that functionality that we might be referring to when we talk about the ADOs themselves. Now, you could independently and directly communicate ADO2 to ADO3, but by utilizing the AMP process, we're able to come to the kernel and say, hey, kernel, I want to have that VFS address. What is the address, what is the resolution for that smart contract address?
And you're not having to track it individually in that, like we're getting rid of contract addresses. That just goes back to VFS.
Right. So it kind of works as this manager that helps to communicate those parts, or the verification process with the ADO database and making sure that this source is a verified set, and a variety of other features that are available there. And when we talk about AMP over IBC, that same communication method where we may be saying, instead of going directly ADO2 to ADO3, I can go to the kernel and I can say, kernel, well, you go talk to ADO2 at this resolution path. And it handles that communication. And once we go into IBC, we wind up with this facility where, because the kernels can be trusted sources, we can now let the kernels communicate in that cross-chain communication. So that same process that we had from a communication from one piece to the other can now be communicated. So ADO3 and ADO5 can be communicated over the kernels without us having to know what is the IBC channel that I'm going to need to do this routing.
So we just take the AMP packet here, right, encapsulate it in IBC, send it over, it unwraps. That's what we do in the OSI model in normal packet management across all systems. Like again, these are the same patterns that we've seen for the last 50, 60 years being reimagined in a capable environment. It needs to be said that something like this could not be done on Ethereum. It would take those guys 30 years to come up with enough ERC patterns, writing this stuff, and it would cost you $400 a transaction because you can't wake up this many contracts. With the Cosmos stack, with Cosmosm, we're able to do a lot of this kind of stuff in a language that makes sense. We're not like trying to do this in Solidity. Good luck doing it in Rust. No, it's a big lift, but it's a lot easier.
And this is just one instance of how that works when we talk about chain to chain. But realistically, what we're going to wind up with the opportunities to do by interlinking all of the various chains is provide this opportunity that you're not going to have to be worried as long as it's involved in the Andromeda connection set, then it's going to have what we need for really radical expanse and access to systems that are not just ours, but that the community has already built, that the contributing community will connect with, and essentially whatever we can be deploying in the Cosmos space, as well as the resources in the external chains that we'll be able to access through, say, Axelar as an example. Really kind of extending the reach of what that is, all handled in the same architectural structure of communication, letting the kernels handle all the communication, the IBC management, and all of those things without you having to worry. And that's where the user accounts come in, because it gets a little convoluted when you start thinking, how do I manage all my accounts, all my keys for every chain, and we're going to be unifying that behind the user accounts. So in that general path set that we said, it's going to be traditionally like you would anticipate. So instead of having a wallet address, you'll be able to have an assigned user account, which will be the equivalent on every one of those chains, so that you can consistently come in and find your resources and your materials and those deployments without having to worry about those implementations.
Perhaps using username at hostname like we do for many other things in the world, like email or whatever, right? There's proper routing behind that. So if you said, hey, just send me $10 in USDT, you can say send it to Cody at and whatever chain, Noble or whatever chain I want it to appear on, and the kernel kind of takes care of all that stuff in the background.
Yeah. So I'm going to go quickly through the tool suite. I got a lot of resources available online that you'll be able to follow up with, and I'm happy to talk with anybody, but we could easily spend 2 hours talking about the tool suites. So I'm going to go quickly. It's just kind of designed to be an introduction, and hopefully when we're done, you'll have enough interest to kind of go do some due diligence on your own about what it is. But in general, I'm going to start out with the web application, which is just a fully featured web app ready to help users read, write, and interact on-chain. Essentially, it's going to manage and consolidate the build-out, in this particular case, a tool set for developers to help us build out these systems that we're talking about so that we can create web applications and other resources for clients and consumers to use on the other side of this. But we start out with we have a couple of different ways to do deployments, and I'm starting out with just a general builder. I can have an empty project, I can save projects, I can share those projects with my teammates, I can re-import those in, and there's also predefined and pre-developed templates to help you with kind of pre-constructed builds that you know that everybody else would potentially have a use for. We will have you'll have your selection of which of the chains that you have that you would like to operate from, and that ADO library that we were talking about, the ALL, essentially giving us those selections of what it is that we might want to go through. And it gives us, in this build, a particularly just simplified format for entering the configuration data that you actually need. So you're not having to worry about what is the standard. Well, the 721 is always going to be a 721, so really it's about how do I get that information in there easily and quickly. And so this is a really straightforward method for putting in that information. But we do have imports and exports specific for in any one of those components as well. That can be saved, loaded, that can be done for all components in build, that can be done for specific ones, and that's something that I can keep or I can share with others. And here's just a kind of a base of a template for an auction-based marketplace, 721, showing us some of the related components and the items that would be used in order to do that. And these are things that the community can be building, knowing that, hey, here's a DeFi solution I think everyone's going to want to be able to do. They'll be able to construct these and release these to the community as well. And we see these builds, so what we were just looking at, we were seeing kind of the implementation process. Once we're done with that, we can see that as a general asset set. So I have some of those general template examples that we have, and we can break those open and look at the individual ADOs inside of them. For this specific CW20 exchange, we've got a CW20 token, and we've got an exchange which handles the sale element for it. Each one of these elements, the ADOs, the apps themselves, each have the contextualization from these context menus for all of the executable actions that would be related to that kind of smart contract, as well as any of the querying options that you might want to be looking at as well. So quick, easy access to each one of those, each one independently loading the specifics for that component in that app. Now in the embeddable side of this, we essentially create a format to allow us to take that same development process we did to kind of package the information that's going to be queried and wanted to be retrieved in a web application or another integration for your data usage. So we see the same development process built out with kind of these data blocks that provide the packaging and consolidation of data that might be wanted to be retrieved. essentially allowing us to kind of do a public-facing publish of that information and data. And we'll be consolidating all of that functionality into one single interface. We have a good portion of it in place now as well. But all of those interactions, the data loading, the instantiation, the executions, the queries, the asset referencing, is all going to be in one kind of power user's playground, allowing you to not have to jump around through different places in order to go and perform those different actions, but have them all at the touch of your fingertip. Being able to figure out more extended routings, manage really large builds, and eventually have some really dynamic input when we start talking about automation and the other pieces that come with that require a bit more of a visual interface for you to be able to really kind of comprehensively understand what it is that you'll be capable of doing. All that functionality is also handled in the CLI. I'm not going to kind of rehash it because it really handles all of that functionality.
But it's important to note that everything that you can do in the drag and drop interface, the WYSIWYG sort of interface, can be done on the command line. So we're using JSON for all the message handling and all the constructs and all the different apps. You can always put that back down. The idea here is that if you've got a large organization and you need to be handling millions of dollars of funds, you probably shouldn't be using a Chrome plugin to manage all your stuff, right? You should probably be using a proper HSM, hardware security module. You should probably be using command line where you have actual control on this stuff. So you can automate things back here on your own for inputs. And the CLI is a really, really important piece to that, because we need to have multiple ways of interacting with the chain, not just through a mouse and keep, you need to have this where you can script it out. There's a lot of cool stuff you can do in here. It's very colorful, as you can see. That also helps.
And just as if you have a preference for the build type with the web application, but like as Cody mentioned, you really, you're not maybe you're not the deployer or something like that. We have a direct export out of the web app, so you can construct your build in the web app the way you want, and then export out to the CLI, which may actually be your management for broadcasting deployment. We're currently, I'm okay with leaving it there.
A lot of middleware involved, yeah.
Yeah, so there's a lot of middleware, and a lot of that is really just trying to make it easier for you so that you don't have to manage how am I going to get access to this, what's the primary information I need off of all the transactions that I've been posting, the asset management, consolidation of data, and we do that with indexers. We've got a GraphQL point that manages all these things as well as we've got a multi-chain SDK.
Really important piece. Middleware is something that we kind of ignore in the space. And every time you bang up against some DEX or some service out there, you're trusting that whatever middleware out there is telling you the right price. I mean, think about it, right? When you go to a DEX and it tells you the price for something, you're not verifying that. You're trusting that some GraphQL server that's running on an AWS instance is giving the right price feed. So if you're going to be running a multi-million dollar concern, you might want to deploy your own. So all this middleware you can run on your own instances. So you trust your own data, you run your own indexers, you have your own copy of the chain. That way you're trusting the data that you generate, not just trusting a bunch of dudes online.
Yeah, but if you don't want to go through the hassle and you do trust us, then we have that handled for you with deployments and endpoints and everything that would be needed.
But I want to stress that we've taken a lot of thought on how we architect these different solutions so that they don't trip up any of the trust violations. There's no crack in here where we've overlooked something. And this approach, this constant approach of how do we properly do this so that it's architected correctly, it's abstracted correctly, that's a really important piece to how we've built this. In order to build something this large, 20,000 lines of code in a kernel, you've got to think about all the different points because you're building a monster.
And so we've been talking a lot more about it at a smart contract level, what would the deployments be, but realistically part of the goal is how do we help facilitate for you to build web applications or web integrations. And that's really where the embeddables come into place, and it's really kind of that we were looking quickly at that packaging, that data that would potentially want to be used. So the embeddables are a general structure that handle all of the communication based off the SDK as the primary layer. But they handle the interactions that you want for data retrieval. They have wallet connection sets, as well as any of the interactions. So if you want to have single action purchases for the marketplace, that's issued in that. We have some primary frameworks for that. Go ahead.
So if you're a Web 2 developer and you're getting into blockchains, your buddies are pushing you into it, and there's a lot of career opportunities, and you get into the space, and the first thing you walk and go, okay, I'm ready to create, what do I need to do? They say, you need to learn Rust, and they go, I'm a JavaScript programmer, I don't know how that works.
Yeah.
Right, so what we've done here is we've really taken away the need to know Rust. You've got all these tools that are available for Web 2.0, JavaScript, and guys that came from Python and these, other languages, I won't say lesser.
Sure.
And so you're able, and even somebody maybe even higher up the stack that doesn't know what JavaScript looks like, right? But they know how to copy and paste an embeddable link onto their Squarespace site. Whoa, okay, so now you're saying we can take all this complexity all the way down to the kernel, right? All these different objects, we've abstracted everything away, all the way up to where you have an on-chain object that you query to get your marketplace with a real quick embed to Squarespace. We've connected the whole thing all the way up. You don't have to go to OpenSea to do this kind of stuff. And right now we're showing NFTs, art and stuff like this.
I'll show more in
It's an easy way to do it, but that's where a lot of people, it demonstrates how simple you can take all this stuff.
Yeah, and that's really what we're trying to do at the moment is just highlight the general kind of where to go with it. And if you think about it in larger scale of integrations versus embeddables are kind of the smaller pieces for a higher integration. So we've got open source build examples specifically in Next.js using Chakra UI and some of the other standards that we would want to see, showcasing the functionality and use that you want for the wallet connection, running a marketplace, some of the ones from the ADOs that we have, so that you can see that reference. It's open source and available, so you'll be able to get that, set those things up with what you have. And we have 4 primary use cases that we've been building against that. One being an NFT marketplace, so the functionality for minting the NFT, the creation, and the sale points for that. We also have one for an auction, an English auction-based example, as well as a CW20 token exchange, just a simple purchase supporting native and CW20.
And this would connect to a DEX of your choosing as a creator. We aren't in the DEX game, we're not in the lending game, we're not in the perp game. You use whatever you want, whatever chain of support out there, and bring it into here and plug it in. So we don't choose winners and losers. We plug into everything that's out there and let you guys, the creators, the end users, decide what they want to do.
As well as kind of just a fixed base, fixed funding, crowdfund. And so these may be good solutions for certain developers or certain creative arts focused people that may want this, but we're really trying to build this so that creators and developers can actually be coming in and creating out that solution and implementing it. We're really right now at a point where we're just trying to showcase what's possible and making it as easy and straightforward with some general boilerplates and some operational examples showing you how to retrieve the data, how to access this. And we have a full set of documentation for every one of the ADOs and everything that we have there. And it's really kind of a lifestyle choice in the development process that we have here. Because we recognize that Cosmos, as many other crypto spaces, are not good at documentation.
We started out with documentation as a very high priority, and we've maintained it for 3 years. So there's really no gaps in our documentation. In order to build in this space, you've got to have proper documentation. We know that because we're trying to develop it, and trying to get proper documentation from any project is a pain in the ass. So we've made sure to really shore that up.
Yeah, so everything that is example gets supported in this side if you get familiar with the space. In addition, we do a lot of write-ups for the general concepts and things like that might be bigger picture or not as technically focused, just to give you an understanding of what that is. But for our less technically inclined people, we also make a good point of kind of easy to follow step-by-step guides for using the systems, showcasing what it is, and we try to build that out in a progressive learning method so that as you walk through 1 or 2 of the examples, you see more and more, and you understand more and more of what you have. So you're kind of constantly building on what you have. We also have support videos for small tasks and things like that, and those are obviously continuing to come as well. I think we're getting close to
Time.
Close out, so we'll move a little quick in kind of some loose discussions with release plans and kind of what we have, kind of on the deck. We have completed our alpha and beta testing. We had about 750 participants at the different stages. A lot of incredible feedback from those guys. We've implemented a lot of things that we think have improved the system based off of that. The best news on my side as one of the primary developers was that most of them were not, it doesn't work. It was, this could be better. It would be, I feel a little lost. And so for me, from my objective of trying to prove that it works and make sure that it's good before we continue to move forward down this path, that was a real testament to me that made me really happy. We're also coming out of audit year relatively soon. I can't put timelines on that because it's a flexible scenario.
It's ready when it's ready.
Run with audits knows how that works. But we'll be looking at a developer preview release onto mainnets here relatively soon, is what I'll put as kind of that. We've got you maybe saw a quick set. We'll have an initial rollout with different sets of kind of our pre-approved chains. That'll be sequential just because we want to make sure that everything gets tested. But we've got a general lineup right now with anticipated support with Terra, Archway.
Secret.
We've got, quite a few in the lineup, and if you've been paying attention to what we have going on in the background, I think you might have an idea of some places you might see this. There's some other additional anticipated features, but I feel like because of time I'm going to have to jump over some really cool points, but I do want to make a point that we're not just looking at small data processing, and big data, processing is going to be a really important part of this. And additionally, we're looking at what is kind of how do things work at the multi-chain level, and how can we all benefit and optimize kind of automational procedural processing. I don't know if we want to go.
Time.
Yeah, for time we'll go through. So I do want to have a kind of call to action, and that's in the contribution space. Specifically, we've got a lot of opportunities for contribution, either as a smart contract developer to contribute to the ADO library, if that's even on a non-technical level to be a community member and support others as they try to learn, or we're calling for here's a need that we know. So we really want to engage the community and get their support in what you want to build, what would make building easier for you. And same for, say, the embeddables. If you're really on the front end side and you don't know about smart contracts and you don't feel like you can engage.
So there's a really big piece on the economics side. How much time do we have? What's our kill time? 4 minutes. Great, I can do this. So if you go back and look and read the free and open source software models of the 1990s into the 2000s, and you look at all the software that was created over the last 30 years, and you see the open source programmers really left empty-handed, while the Facebooks and the Microsofts and the Googles took that free software and made billions off of it over the last 30 years. And there's a fundamental piece here that we need to change. Open source programmers need to be paid for their work. And I don't mean cornering a market and having some billion-dollar, you spend a weekend programming something that everybody uses and you get $1 billion in the next 30 years. I'm saying that with this economics engine, you're able to put, say, just 5 cents every time you use this ADO. Over time, that goes down to 4 cents, down to 3 cents, down to 2 cents. And this is all managed through the DAO, so there's a stepping piece there. And the kernel enforces that, right? So eventually this stuff gets paid off over time. But you're paying 5 cents, you're paying 3 cents, 2 cents to use these ADOs, and that encourages the developers to come in and get paid for it. So as a developer, you can say, well, yeah, I'll pony up some code, I'll write some stuff here. I don't need to tokenize everything, right? We can't tokenize every piece of software out there, but we can put a payment system in place so that the developer gets rewarded for their work. They're guaranteed that, but over time, they don't hold the community over a barrel by saying you're going to have to pay me 5 cents every time you use it for the next 50 years, right? There's this homeostasis there. So if you go back and you read Eric S. Raymond, what would they have done when they were writing the free and open source software mantras back in the 90s if they had blockchain? That's the question we need to be asking ourselves. How do we change this fundamentally?
Yeah, so we've implemented that in AMP as one of the fundamentals for the key systems. We'll be coming out with a series of bounty programs as well, and we have some general, if you'll keep an eye out, we've got some hackathons and some other things that'll be coming out and some announcements with
Dora Hacks, actually.
Yeah. And a couple other names that I'm pretty sure you would recognize. So really, I appreciate your time. And thank all of you. If there's any questions and we have time, happy to work with you. This will get you access to most information. If you want to scan a QR, we've got that, but we'll happy to talk to you in person as well.
Preferably outside.